In this video, we're going to talk about real numbers. Right now, real numbers are any type of number you've ever learned about so far. Not just whole numbers, not just positive and negative with integers, but any numbers you've ever heard of. When it comes to plotting numbers on another number line, we don't always plot them right at the tick marks, at the lattice points that we see there. If we wanted to plot 1.3, we would know that 1.3 is 3/10 of the distance between 1 and 2. And if we could put in 10 little hash marks and count 3 out, we would. Or we could just know that it would be right about there on the number line, and we'd plot that as 1.3. If we want to plot something like negative 2.1, that would be just a little bit to the left of negative 2, and we would label it that way. Notice how negative 2.1 is to the left of negative 2, and that the numbers on the negative number line go in the other direction compared to what they do on the right-hand side. Now, when it comes to inequalities, it's important that you know what we're talking about here. This first symbol is the less than symbol. The second one is the greater than symbol. And then we have the less than or equal to and the greater than or equal to symbols. Now, I don't want you just to be able to insert the proper number between two numbers. I want you to be able to pronounce which one is which. So many people get used to the type of problem where we say, here's negative 3 and here's negative 5. Insert the proper inequality. Well, since negative 3 is bigger than negative 5, this would have the greater than symbol there, and we would read that negative 3 is greater than negative 5. Now, we understand that 5 is bigger than 3, but because the number line runs in the other direction for negative numbers, this would be the proper answer. Now let's talk about rational and irrational numbers. Rational numbers are any number that can be written as a fraction of two integers, provided you're not dividing by 0. The key word here is fraction. If you have 3/5, it is a rational number. If you have the whole number 4, it is a rational number also because it can be written as a fraction, 4/1. If you have the square root of 9, that is rational because it is equal to 3, which in turn can be written as 3/1. What then is an irrational number? Well, it's a number that cannot be written as a fraction of two integers or as a repeating decimal. A key example of this would be the number pi. It is approximately equal to 3.141529. But it's not equal to that. This number goes on and on and on forever, and you can never put a bar over any of these digits and say these are going to repeat over and over and over again. This is what an irrational number is. That's why I used a squiggly equal sign here to say it's approximately that. What is the absolute value of a number? Well, basically, it's its distance from 0 on the number line. If I want to know what is the absolute value of negative 3, I could look at the number line and say, okay, negative 3 here is 3 units away from 0, and so the answer would be 3. The absolute value of negative 3 is 3. Now, some people mistakenly say, oh, the rule of absolute values is the change of the sign. So if I had the absolute value of 2, it would be negative 2. But no, that's not true because the number 2 here is 2 units away from 0 on the number line, and distance is always positive. So absolute value symbols always make whatever is inside of it positive. Now, let's say we had the absolute value of 4 minus 10. You have to do the math problem inside the absolute values first. 4 minus 10 turns out to be negative 6, and then the absolute value of negative 6 is positive 6. If you tried to take the absolute value of 4 and the absolute value of 10 separately and then subtract, you would have 4 minus 10, which is negative 6. And that would be a different answer. You have to do the math problem inside the absolute values first. Now, if you have a negative outside of an absolute value like this, the opposite of the absolute value of negative 7, you cannot cancel these two negatives out. You are going to do the absolute value operation first to get 7, then multiply by this negative 1 out in front to get negative 7. Now, the opposite of a number. The opposite of 5 is negative 5. The opposite of negative 11 is positive 11. Basically, it's what you get when you change the sign of a number. Now, if you have x, the opposite of x would be negative x. Now, something that's a little bit confusing, if I asked you which of these two is positive, most people would say, x is positive and negative x is negative. But that's not actually true. X is a variable which can represent any number. So maybe if x is negative, the negative x would then be the opposite of a negative, which becomes a positive number. So don't be fooled into thinking that just because there's no minus sign out in front there, that this isn't negative. It could be, or it might not be.